Okay, in this video, I will explain how to compute the Laplace transform inverse of this function. Let me remind you that we already know that the Laplace transform of a constant function is a over s. The Laplace transform of e to the at is 1 over s minus a, and the Laplace transform of t to the n is n factorial over s to the n plus 1. We can see these formulas like in the other direction. We can say that the Laplace transform inverse of a over s is a. The Laplace transform inverse of 1 over s minus a is e to the at, and the Laplace transform inverse of n factorial over s to the n plus 1 is just t to the n. The idea is to rewrite this expression. We're going to rewrite this expression 2s cubed plus s squared plus 3s plus 2 over s cubed times s squared minus 3s plus 2. I'm going to rewrite it using partial fractions. And then before we start doing partial fractions, we need to check if this is irreducible. To check that it is irreducible, we do b squared, which is 9, minus 4 times 2. Is this smaller than 0? It is not. That means that somehow we can factor it. And actually we can factor this by we can factor it as s minus 1 times s minus 2. We can check that s minus 1 times s minus 2 is s squared minus 3s plus 2. Now we have this as a we have this completely factored. Then by partial fractions we can write this as a over s. Notice that this one has multiplicity 3. Then we have to do plus s squared plus s cubed. Right? We do it like this. And then on top of a linear term, I have to just write a number. And this is also a linear. Then it will be s minus 1 times d plus e s minus 2. Then we need to find a, b, c, and d. Then we have to make sure to write as a common denominator exactly this denominator. Right? Then we write the common denominator to be s cubed times s minus 1 times s minus 2. And then what is missing the s? What factor is missing the s to be the whole denominator? Then we have a times is missing an s squared times s minus 1 times s minus 2 plus b. What is missing the s squared to be this denominator? Is missing an s times s minus 1 s minus 2 and plus c. What is missing the s cubed to be this denominator? S minus 1 times s minus 2. And I just realized that this is not going to fit here. Let me just continue here. Plus d times, what is missing s minus 1 to be this denominator? Is missing s minus 2 times s cubed plus e times s minus 1 times s cubed. Then we want, now we have a fraction with where the denominators are the same. Then we want the numerators to be the same. Essentially, we want this numerator, right, this numerator, I want it to be equal to this numerator. Let's expand this numerator now. Actually, maybe it's a good idea to rewrite this as s squared minus 3s plus 2. And just this. Then when I expand this part, I will get an a s to the 4 minus 3a s cubed plus 2a s squared, right? This is this part, and expanding this part, plus, and remember that this part is s squared minus 3s plus 2. Then this is plus b s cubed minus 3 s squared plus 2, sorry, I forgot to write the b here, plus 3 b s squared plus 2 bs, right? And I have taken care of this part. Plus, remember that this s minus 1, s minus 2 can be seen as s squared minus 3s plus 2. Then we have here plus c s squared minus 3s plus 2c. And then we continue with this one, plus d s to the 4 minus 2d s cubed plus e s to the 4 minus e s cubed. Okay, now we need to set up the coefficients. These two polynomials are the same, and then they must have the same coefficients. We do the coefficient of s to the 4. Notice that this polynomial q is a polynomial of degree 5. Then we start with degree 1 less. Coefficient of s squared, coefficient of s cubed, coefficient of s squared, coefficient of s, and the constant coefficient. Then, what is the coefficient of s to the 4 of the left-hand side? We notice that there is no s to the 4. That means that the coefficient of s to the 4 is 0. And the coefficient of s to the 4 on the right is, we have this one, and a. What else do we have? Plus d. The coefficient doesn't include the s to the 4, it's just the number that is next to it. And then plus e. Then we have our first equation, a plus d plus e equals 0. The coefficient of s cubed on the left, it is 2. And on the right, we have a negative 3a, which is this one, plus b. What else have a s to the cube? Let's keep going. This is already taken care of. Minus 2d minus e. This is already taken care of. The coefficient of s squared on the left, it is 1. And on the right, we have a 2a minus 3b plus c. And what else? Plus c. We're doing s squared, and that's it. Coefficient of s. The coefficient of s on the left is 3, and on the right it is 2b. There is a mistake here. It's supposed to be minus 3cs, right? Minus 3c. The coefficient of s, yes, minus 3c, yes, minus 3c, and that's it. And the constant coefficient on the left is 2, and on the right is, let me see, this is the coefficient of b, which is already taken care of. This is just 2c, right? And that's it. Then we solve the system. Let me check. That means that, let's solve the system. From here, we have that c must be 1, right? From here, from the last equation. If c is 1, then we have 3, negative 3. b must be, 2b must be 6. That means that b must be 3, right? And if c is 1 and b is 3, let me rewrite this equation. We have 1 equal to a minus 9 plus 1. Right? We have that. And that means that a must be, this 1 and 1 cancel, a must be 9/2, right? And when I replace here, when I replace here this equation, I get that d plus e must be equal to negative a, which is negative 9/2. And from here, we have that negative 2d minus e must be equal to 2 plus 3a minus b. And let me see, what is that? Let me write this here. A is 9/2, right? We already know that. And we are solving just for d and e. Everything became just these two equations. We have d plus e equal negative 9/2. And here we have negative 2d minus e equal, what is this? This is a 2 plus 3 times a. 3 times 9/2 minus 3. This is just 27/2 minus 1. And this is 25/2. Then this is 25/2. How to solve this system? We can add the two equations. What happens when we add the two equations? We get negative d equal, we are adding the two equations. 25 minus 9 is 16. 16 divided by 2 is just 8. That means that d is negative 8. Let me check that answer. D is negative 8. And then we can solve for e. How do we solve for e? We have that d plus e is negative 9/2. And we know that d is negative 8. That means that e is negative 9/2 plus 8. And this is negative 9 plus 16 over 2, which is, what do we have here? 16 minus 9 is 7/2. 7/2. That means that e is 7/2. Let me check that. Okay. That means that I have found the coefficients, and unfortunately I erased those, but let me just remind you, essentially the Laplace transform inverse, this fraction can be written like a over s, 9/2 over s, plus b over s squared, which means 3 over s squared, plus c, what is c? What is c? Plus 1 over s cubed, plus d over s minus 1. What is d? Negative 8 over s minus 1, plus e, 7/2 over s minus 2. Right? We have that. And let me remind you that the Laplace transform of, I erased that, but the Laplace transform of t to the n is n factorial over s to the n plus 1. In particular, the Laplace transform of t is 1 over s squared, and the Laplace transform of t squared is 2 over s cubed. That comes from here. But then, let's see what is this. the Laplace transform of a number over S is, the Laplace transform inverse will be just 9/2. The Laplace transform inverse of 3 over S squared, we have, this is just a 3t, because the Laplace transform of 3t would be 3, and the Laplace transform of t is 1 over S squared. 1 over S cubed. 1 over S cubed. Let's see. I can write this. 1 over S cubed can be written as 1/2 times 2 over S cubed, right? But 2 over S cubed is the Laplace transform of t squared. That means that this is 1/2 of t squared, right? What else here? Now we are going to use this formula. Minus 8, and this is the Laplace transform of e to the t, right? And we are going to use this formula again with a equal to, it will be plus 7/2 e to the 2t. Then the answer, what is the Laplace transform inverse of this function, is this function here. Notice that most of the work was to do the partial fractions. That was the difficult part, and you will see in this type of problems that in most of the cases you have to do partial fractions. Okay, this is it for this example.